Lesson number 3. This one is on triangles and different types of triangles. So get your notes set up. If you've already got your title up top, make sure you fill in your top right-hand corner with your name, your class period, and the date. And then our essential question: how do the angles and sides of a triangle help in identifying it? So some of these may be familiar for you, but we want to review them, make sure they're still fresh in our memories. We can classify a triangle by its angles. Here's a key. Jot this one down. A triangle always has at least 2 acute angles. Remember, a triangle has 3 angles. It's the third angle that decides what kind it is. So you can't just look and see, oh, I found an acute angle, it must be an acute triangle. Every triangle has acute angles. It's what the third angle, or all of the angles are, that really decides what it is. So we have 3 types. We have the acute, we have right, and obtuse. The acute angle is all 3 angles are acute. So all of the angles are less than 90 degrees. So you might see it look something like this. Okay, notice each of the angles are all smaller than a right angle, all smaller than 90 degrees for us. A right angle, well, the name gives it away. If you see a right angle anywhere in a triangle, it's always going to be a right triangle. It can't be acute, it can't be obtuse. If it's got a right angle, it is a right triangle. The other 2 are little acute angles, and then we have our one right angle. Last one is our obtuse angle. Obtuse is one big, wide open angle, and then 2 smaller acute angles. But always look for that big, wide open angle. That's how you know you're looking at an obtuse angle. Don't pay attention to little ones. Look for that one big angle. If you got one of them that's bigger than 90 degrees, you know that's going to be our obtuse angle. So you can classify a triangle by its angles. If they're all acute, it's an acute triangle. If you have one right angle, that's a right triangle. And if you have one obtuse angle, that's going to be an obtuse triangle. Going in the other direction, you can classify a triangle by its sides. The key is, and again, jot this down, look to see how many congruent sides the triangle has. So first we have our scalene. All of the sides have different lengths. So it might look like one short one medium one, and then one longer one. Here, when all the sides are the same, all the angles have different measures as well. So you can't have 2 measurements that are this, or 2 angles that are the same size if the sides aren't also the same size. So scalene is everything is different lengths. Isosceles. This is the hardest one to spell, so it's going to take some practice, but it's where at least 2 sides, and usually it's exactly 2, but technically it could be more than that. At least 2 sides have the same length. So a lot of times it's going to look something like this. A nice symmetric triangle here, where these 2 opposite sides are congruent. And we're going to know that because of the markings on them. We call these tick marks, but any side in a shape that has the same number of markings on it, we know are congruent to each other. It's kind of our shorthand for saying, hey, these 2 sides are the same length, they are congruent. The nice part is the angles opposite the equal sides are also congruent. So if these 2 sides are congruent, then the angle, this side, the angle across from it, and this side, the angle across from it, these 2 angles are also going to be congruent to each other. So if it has 2 congruent sides, it has 2 congruent angles. And then last is our equilateral. All 3 sides the same length. So I'll do my best to draw this one out, but it's hard to draw them all perfectly. But all 3 sides would be marked the same way because all 3 sides are the same. And just like over here, if the sides are the same, the angles are the same. So in this case, all 3 angles have the same measure. An equilateral triangle is also called an equiangular triangle, meaning it has all 3 sides that are the same length, but all 3 angles are also the same. So this angle, and this angle are all going to be the same measure. If the sides are the same, so are the corresponding angles. So we've talked about how to classify a triangle by its angles, an acute, a right, and an obtuse triangle. Then classifying it by its sides, a scalene, an isosceles, or an equilateral. No sides the same, 2 sides the same, or all 3 sides are the same. Last little bit of a triangle. All of the angles in a triangle always add up to be 180 degrees. Doesn't matter what kind of triangle it is, it doesn't matter how it looks. If you were to take all three angles in any triangle, they're always going to add up to be 180 degrees. So this is where you're going to have to do a little bit of math. If we know they add up to be 180 degrees, that means we can work backwards to figure out a missing angle. So take this one up here. We know that this angle up here is 119 degrees. This angle here is 43 degrees. They just couldn't fit it in here, so they wrote it off to the side and drew an arrow, meaning we don't know how big this angle is. Well, we know that if I were to add up all three angles, it has to equal 180. So it's just an equation. We go ahead and we solve it. 119 plus 43 is going to give you 162 plus, I don't know. So I subtract 162 from both sides, and I get x is equal to 18 degrees. So my missing angle up here is 18 degrees. All three angles have to add up to be 180. So same thing here. In triangle ABC, the measure of angle A is 25 degrees. The measure of angle B is 108 degrees. What is the measure of angle C? Well, first thing you should hopefully notice is 108. Definitely an obtuse triangle. It's got an obtuse angle. But we know that the measure of angle C plus the measure of angle A plus the measure of angle B has to equal 180. So C plus, that would be 133 is equal to 180. And then it's just solving an simple equation. C is equal to 47 degrees. So the measure of angle C is 47 degrees. Add them all up, subtract from 180. Next one here. You would be surprised at how many people get stuck in this one. They're like, Mr. McKenzie, they only gave us one of the angles. It's only 30. No, they gave you two of the angles. They just didn't write a number for one of the angles. Remember, anytime you see that right angle symbol, you know a right angle is 90 degrees. So that symbol is as good as writing 90 degrees. So add all of our angles up. X plus 90 plus 30 is equal to 180. So x is equal to, or x plus 120 is equal to 180. Subtract my 120, and yes, I want to see your work. And x is equal to 60 degrees. So my missing angle up here is going to be 60 degrees. Last one, a little different, so I'll switch up my colors, but it's the same idea. Add together all three angles, and they have to be equal to 180. So x plus 2x plus 90 is equal to 180. X plus 2x, well, it's really 3x plus 90 is equal to 180. Subtract 90 from both sides, and I get 3x is equal to 90. And then, of course, x is equal to 30 degrees. Of course, you can do a better job of showing your work. I just kind of ran out of room there. But then don't forget to go back and put those measurements in. So x is 30 degrees. 2x would be 60 degrees. And we know that this right angle was 90 degrees. So all three angles in a triangle always add up to be 180 degrees.